week, we came up with a couple of different formulas for finding the interior sum, the sum of the interior angles of a polygon. Who remembers those two formulas? Anybody? Yes, give us one.
N times 180 minus 360.
Okay, the other one?
Minus 2 parentheses times 180.
Okay. This one came from thinking about it how?
Triangles inside of here.
Triangles, they're both triangles inside.
By going from the center and then to each vertex.
So we took a polygon of n sides, and I'm not even going to finish this one up. Put a point somewhere in the middle, and the number of triangles formed is always going to be what?
2 minus the number of sides.
It's going to be
The same number of sides.
I'm going to draw one of these to each vertex, so there will be how many triangles in here?
Same number of sides.
Same number as the number of sides, right? And each one of them has a sum of what for its interior? 180. So we take the number of triangles n times it by 180, and that will give us the grand sum, except for what? We don't know how many of these there are, these triangles, but there will always be 360 degrees in the center that are not a part of our interior angles as we go around, and so we have to subtract that out. Okay, how did we come up with this one?
Making triangles that start with one vertex and go to all the other sides.
Okay, so we drew in starting at one vertex, we drew in all of the diagonals we could, just from one vertex. And the number of triangles formed now is always what?
2 less than the number of sides.
Why is it 2 less?
Because you can't use the 2 that are right next to it on either side.
There will be each of these sides will have a triangle associated with it, right? Let's put a couple more up here just to, okay, so each triangle has a side associated with it. Let's see if we're going to go that way. But this one doesn't and this one doesn't, so it's always 2 less, right?
Bless you.
Now, this time we multiply by 180 and we don't subtract. Why not?
You already subtracted 2.
Yeah.
You need to count
Notice,
all those in.
These two angles were added up when we did the 180 for this one, right? And this one was added up when we got the 180 for this. So each of these are all interior angles. That's not very good. 1, 2, 3, 4. These 5 angles make up this one. So there's nothing to subtract out. Does that make sense? The reason we subtracted 2 is because we have 2 less triangles. Okay? I think it's helpful to know both of these and know where they come from. For your homework, you were asked to go home and see what you could come up with for a formula for the sum of the exterior angles. So I'd like you to turn to a partner in class and discuss what you came up with and how that made sense to you. Exterior. What was exterior? Yep.
I had 180 minus that formula, the n minus 2 times 180 divided by n.
Say that again.
180
Minus this one?
That one over n. So n minus 2 times 180 over n.
All
No.
over n or just this
Just
one?
that second part.
This one over n.
The reason being that second half of it will give me the value of any angle at a vertex, and I subtract that from 180 because going out from, continuing the line from that vertex will give me a straight line. And so when I subtract the amount in the for the interior angle, it gives me the exterior angle.
So this here is not the sum, it is for one
That's just
exterior
one
angle.
So you have
yeah,
to multiply
sorry.
the entire thing by n.
Yeah. What she said.
So let's see. This is equal to one exterior
My bad, jump the gun.
angle right here. Does everybody see what he's saying? That this one here is the sum of all of them. If I divide by how many there are, that will be the how much each one is on the inside. So that's this here. By the way, your formula fits for regular polygons, not anything, because if you're going to divide by n, you're assuming they're all the same size, right? That would give us this, and then you take a 180 minus this, and that gives you that. All right, and then what somebody came up with a way to multiply all of this. This is for one, and so if there are n of them, I could take this whole thing times n. This is interesting. And now I have the sum of the exterior angles is equal to, and that is for regular polygons.
What should work for any type will always give you the 360, and you'll always
When
have
you
the
just-
Why don't we do a little algebra on this and see what we come up with? Distributing the n across the subtract sign, I get 180n minus,
2.
this cancels, right? So I've got n minus 2 times 180. Distributing this, we get 180n minus 180n plus 360, because minus a minus, when I go that times that and go minus, right? And what's this?
0.
0 plus, we get 360. Right? Were you surprised that the formula, or that the amount didn't change with each of the, as you added more sides? No? Was anybody surprised?
I was surprised.
Since this changed, right? Wouldn't we think this would change as well? Well, a little demonstration, and you actually saw this on the GeoGebra applet, but what I'm going to do is I'm going to illustrate it right here with this pentagon on the floor. You'll notice the pentagon is irregular. It's got some exterior angles on it. What I'm going to do is stand in the middle, and what I'd like you to do is watch my body as I walk around this polygon. So as I move around, okay, I'm turning at each vertex. How far am I turning at each vertex, by the way? The same as each exterior angle at that vertex, right? Facing this way, and now I turn through that. I come up here. Does everybody watch my body? What did it do? 90 degree? 90 degree would be here. I'm facing this direction now. Or when I started, and I'm facing this direction again. I either didn't turn at all, or else I did. Watch again. Now I'm 180 because I'm facing that direction. I come back and now I've finished another 180, so I've turned 360. And you'll notice I've turned through each of these exterior angles. Does that make sense? What if this were a hexagon? I would still walk around it once, right? And my body would turn once. It doesn't matter how many sides it's got, because we'll turn through these exterior angles each time. Did everybody see how that worked with bring this? By the way, when you're working with GeoGebra, did you notice that this thing comes up because it wants to run Java? You can hit cancel for most of them and click down here, view as an HTML5 applet. By the way, those of you who are into iPads or smartphones, you can actually run GeoGebra on those if you'll click on that. I think it actually detects that you're on an iPad and converts it to HTML5. And this isn't what I wanted. That's not. Where's the one that has the car driving around it?
Good question. I
Huh?
don't think we had one.
Out the exterior sum. This was kind of an interesting way to approach it for these regular ones. Yes.
So I understand how you got to 360, but why did you start off by multiplying by 180 at the very, very beginning? The second one, sorry.
Here. Because of the distributive property here, parentheses times
Okay,
this.
just because it would get 360.
Well, I wanted to get
Okay.
360, so I was doing algebra to see if I could get there.
Okay.
Okay, that was my purpose.
Okay.
Okay, does everybody see where this came from? Here we've got our sum, which means there's each interior angle. 180 minus each means we take the interior angle minus subtracted from 180, that gives us the exterior angle. So this is one exterior angle times the number of sides would be n if they're all the same. And you can actually come up with it that way as well. Okay. You interacted with a GeoGebra app that helped you learn some things about quadrilaterals. Would everyone please pull out their homework, where there's the sheet here where you identified those characteristics of the quadrilaterals. With your partner, I'd like you to compare your answers. If you have any differences, or if there's one you weren't quite sure about but you filled it in because you thought it was this, talk about the ones you weren't sure about or ones that that you have a difference in, and then we'll talk about these.